Thank you, Ola Fadiran, for joining us today. Over to you.
Thank you, Fumi, and thank you, Emeka. I think the deep tech community is one of a kind. It's something that's needed for the ecosystem. When I set up to participate in this, I wasn't aware of the 15 minutes limitation. 15 minutes is not nearly enough to talk about hardware and AI and all of that. So I thought about, okay, what can I do in 15 minutes? So what you would see is an idea of we're going to play with the number 5. So I'll show a series of slides and just talk through it to give an idea of some of the key points around the hardware space. And then I think then we'll maybe do questions later. So I'll share my screen now. So we'll play with the number 5s. I have a number of slides, talk about fives. Okay, so I'm Ola Fadiran, founder and CEO of ChipMango. ChipMango, we're a global semiconductor solutions partner. What that essentially means is that we pick problems in the semiconductor ecosystem, and then we partner with the semiconductor companies on how we can solve it. And behind all of that is the Africa ecosystem in mind. So the first 2 solutions we've picked are the workforce, the semiconductor workforce. How do we bring the continent of Africa to become a key player in the semiconductor workforce? And then the second problem that we're solving is the cost of microchip design. How do we reduce that cost? So So I said I'll play with the number 5s in 15 minutes here. So the first thing to talk about is microchips is the bedrock of AI. As you know, the AI we see the software, the interface, but beneath all of that is the hardware layer. So without the hardware, there can be AI. And in fact, I think one of the things that proliferated AI was the discovery of microchips that could handle the workloads and could handle the algorithms as massive parallelization and massive computation, massive matrix multiplication. And so the hardware originally developed by NVIDIA, focused on gaming, was then reappropriated to AI, and that's what kicked off the entire explosion. So there is no AI without hardware. Hardware is the bedrock. So just what are some 5 everyday gadgets, just to show this very simple point of our phones? I think most of us in this webinar have a phone, 1 or 2 phones, and there's extensive AI application in there. In our homes, we talk about the smart homes with voice assistants, thermostats, all sorts, connected homes that goes to connected cities, and you could even talk about connected mega cities. These are all powered by AI, which runs on hardware. I like this session right before this, talking about XR. The XR devices are also running on hardware, with fitness trackers, smart watches. Also, it's all running on AI applications. They're running on hardware. Cars, maybe not the truck in this picture, but cars is also a key product that we use every day that has AI extensively in there. And of course, we do a lot of streaming, and AI is actually implemented in the hardware. It's the bedrock of that. So again, any AI application that you see beneath all of that are the microchips. And that's what's really running the computation behind the hardware. There are more gadgets, as you know, but we're playing with 5s today. So every slide would have 5 something on it. So the next one is 5 important facts about AI. I like to say we're in a period right now like no other. I think, we're seeing a massive disruption across every single space. I don't think there's any application that wouldn't be touched by AI. We've seen explosive growth all around. And, from an Africa standpoint, there is no better opportunity than right now for Africa to really come and play a big part. I think there is really a pathway for us to, for the continent to become a key part of this ecosystem and be part of that explosive growth. And really, that's from the foundations. And everyday AI, we see data on green models, a lot of massive data. AI is scaling with data. I think more recently, there's been talk about reaching maybe a tipping point when it comes to data improving the performance of the AI models. But the hardware is still being designed to be able to handle the massive amount of data that's needed. Now we're starting to see specialized hardware in AI. Some of the NVIDIA chips were more general purpose, and there is now a shift to more custom ASICs for AI application. We're seeing an emergence of that, specifically with Broadcom. Broadcom is really the company that's, I think, is leading some of the custom ASICs. There are startups that are in this space. I think we have some of those startups in the panel today, potentially. There's massive global competition. So in AI, in the hardware space, we're seeing emergence of regions globally that are wanting to take a key part. We're seeing Vietnam, a lot of movement in Vietnam. We're seeing things in Malaysia. Of course, India is making intense progress, right, in this space also. A lot of that is impacted by the geopolitical tension between the United States and China. That's presenting an opportunity for many regions. ChipMango, we believe that Africa is also going to be one of those in terms of the microchip space. We see a future where the fundamental building blocks of microchips is a skill set that is proliferated across the continent. That's one of the big problems we're working to solve. Okay, 5 microchip design steps driving AI. So in this one, I'll take you a bit into the microchip design space, what is done very quickly. In order to have your chip, you start with the concept and the architecture. This is where you define the chip's purpose. Is it a GPU? Is it ASIC? ASIC, which is application-specific integrated circuits. That's where you have more tailoring. Or is it the FPGA, which is a field programmable gate array? That's more general purpose hardware that can be programmed to do a specific task. And from the architecture, you determine the system of architecture. Then you go to RTL and verification. RTL stands for that's the register transfer language. This is where you write the code. It's almost like software for hardware. I always call it, it's software for hardware. In Africa, we see a lot of software solutions. This is the software for hardware. So how you write the code that determines the way the microchip will behave. How you simulate the behavior of the microchip in the digital world. Companies like Cadence are leading in the space in terms of the tools that are used for RTL and verification. And from RTL verification, you have physical implementation. This is when you take your design and then you place each of the units of the design, you place it into the chip. And there are tools for that. You're laying out the circuitry, you're determining the power and the performance, you're making trade-offs on that, how fast your chip would run. Cadence also has a slew of tools that help with physical implementation. Then the next is the fabrication. So fabrication is more what we're familiar with. I think in Africa, when you talk about microchip design, most people think about fabrication. But as you can see here, there's a slew of work that's done. There's so much work that's done before the fabrication. In fact, many companies that we know as microchip companies are not even in fabrication. So TSMC is the key player in fabrication. We have other companies like Global Foundries that are there. the fabrication technology is one of the key tension points in the geopolitical space between the United States and China. So once you've fabricated your chip, the chip is then physical, and then you now need to test, and then you iterate on the testing, and that's the last step there. So that's it's called post-silicon testing. You validate your prototype, you optimize your performance. You can do refine based on your yields, fix things, and then you hope to get better yield. And there are key companies that also work in this space. So 5 microchip design steps that are driving AI. So I thought it was good to talk about some of the emerging trends in AI chips. And I think here we're just talking about what are some of the key points that are driving the future of this space. We see a push towards chips more and more mimicking the human brain. I think part of that is, I think the brain is one of the most efficient chips right now. And you look at the amount of power that goes into the data centers, and I believe the brain is maybe even still stronger than the data centers potentially. And we definitely do not burn that much power in our brains. So the designs are trying to mimic the brains more and more. We're seeing more customization, like I said earlier. In the physical space, you're starting to see more stacking, 3D stacking, and more protocols that are really tied towards the 3D stacking. Power being a critical issue, we're looking at more efficient designs in the hardware space. How do you perform the same amount of computation with lower power? Some of that innovation comes at the system architecture level, but some can also come at the lower level where you're doing your design. You do like more clock gating and your architecture design in a way that you use different power domains and things like that. So we've seen a lot of innovation around in that space, and more and more focus on the quantum like effects, quantum computers. Regular computers use the binary quantum. They have more degree of freedom, so you could compute a lot more with a quantum chip than you could do with a computer. I think more recently, the projection for usable quantum computer is in the next 10 years. And then the final slide here is, okay, we talked about a bunch of things. What are some ways to get involved in the hardware space? Hardware microchip design being the bedrock of AI. The software is built on the hardware layer. One of the things we're working on at ChipMango is we'll be launching an e-learning platform that allows for learning in this space. So the plan is to proliferate this platform across Africa so we can get the youth and the people in Africa to learn this very rare skill from the ground up. We believe once we do this, then people know how to build the chips from scratch. We would see more and more applications. We'll see more and more applications. So of course, as you know, join communities like this one we're on, do hackathons, AI forums. That's where the information is. Get your hands dirty by building prototypes. Follow the leaders. Use the kits. Follow the news. Collaborate internationally. The semiconductor ecosystem is international. It's a network across the entire planet. So make sure to reach out and communicate internationally. And yeah, that's all I add for today. And thank you, Fumi and Emeka, for the opportunity to speak at this event. And looking forward to the questions.